I want to tell you something before we begin. The speed of light is not really a speed limit at all. It is a thread, fine and strong, stretched through everything that has ever happened, holding your yesterdays behind you and your tomorrows ahead, keeping every cause before its effect for every soul in the universe. And tonight, we are going to ask the most dangerous question there is. What would happen if that thread were ever cut? What would happen if anything, a ship, a particle, a single radio signal, ever managed to outrun light? So let the world go quiet, get comfortable, and subscribe if you'd like to drift along with me. The answer is gentler and stranger than fear. Part 1. The message that stops itself. Imagine you press a single button, and a pulse of radio leaves your transmitter and races across empty space faster than light itself. Now imagine that the reply to that pulse comes back to you, lands in your receiver, blinks its little confirmation light, and does all of this before you ever press the button in the first place. Not a moment after, not at the same instant, before. The answer to your question arrives while the question is still an idea in your mind, while your finger is still hovering, undecided, over the button you have not yet touched. That sounds like a mistake, or a magic trick, or the kind of thing only a very tired person would say late at night. But it is none of those. It is a careful, sober consequence of the physics that runs this universe. And tonight we are going to follow it all the way down, slowly and patiently, until you can see exactly how it works and exactly why it matters. Here is where it turns from strange into impossible. Suppose you are a careful person and you decide to add one small rule to your transmitter. The rule is this: only send the pulse if no reply has already arrived. That is a reasonable rule. You would not want to send a message you had already been answered, would you? So you wire it in. If the receiver is silent, the pulse goes out. If the receiver has already blinked, the pulse stays home. Now sit with what that rule does, because it is the whole video in miniature. If you send the pulse, the faster-than-light reply comes back into your past. The receiver blinks before you sent, and so your own rule forbids you from sending. But if you do not send the pulse, then no reply ever comes. The receiver stays dark, and so your own rule commands you to send. The message goes out if and only if it does not go out. It is answered if and only if it is never asked. You have built, out of nothing but a radio and a rule, a knot that the universe cannot tie. You might reasonably want to stop me right here and object that this is plainly absurd, that messages simply do not arrive before they are sent, that radios do not tie themselves into logical knots, and that therefore something in my little setup must just be wrong. And if that is your reaction, you are in the finest possible company, because it is almost exactly the reaction that Einstein and the physicists who came after him had as well. But here is the subtle and important thing, the thing that turns a parlour trick into a profound truth. They went looking for the error, and they could not find one. Every single piece of the argument we will build tonight is made from physics that has been tested to staggering precision, confirmed in particle accelerators and atomic clocks and the satellites that guide your phone, millions upon millions of times, never once failing. The tilting of time is real. The disagreement about now is real. The only thing we will slip into the argument that has not been confirmed by experiment is the very first ingredient, the granting of a faster-than-light signal. So when the argument runs all the way down and ends in an impossible knot, there is only one place that impossibility can be leaking in from. Not the radios, not the rule, not the mathematics. It can only be coming from the one unconfirmed assumption, the signal itself. The paradox is not telling us that logic is broken. It is telling us, in the clearest voice physics has, that the signal must be forbidden. And that is a very different and far more interesting thing. I want to be honest with you right at the start, the way a good guide is honest before a long walk. This is not a story about technology being difficult. Most people, when they hear the phrase faster than light, picture a problem of horsepower. They imagine that the trouble with crossing the cosmic speed limit is the same as the trouble with crossing an ocean in a rowboat, that it is merely very hard, that with a big enough engine and enough patience we would get there. That picture is wrong, and the way it is wrong is the most beautiful idea in all of physics. The trouble with going faster than light is not that it is hard. The trouble is that it breaks time. The title of tonight's journey says it plainly, and by the end you will feel why it is true in your bones. Going faster than light is not really about speed at all. It is backward time travel wearing a clever disguise, and backward time travel can always be folded into a contradiction like the one we just built, a message that cancels itself, a cause that erases its own effect. There are, it turns out, two different reasons the universe forbids us from outrunning light, and almost everyone only knows the first one. The first reason is about energy. It says that no ship, no rocket, no object made of ordinary matter can ever be pushed up through the light barrier, because the closer you get, the more impossible the next sliver of speed becomes. That reason is real, and we will spend some time with it. But it is the weaker of the two, and it is the one with loopholes. The second reason is about time itself, about cause and effect, about the order of before and after. That reason has no loopholes, and it is the one that truly locks the door. Tonight we are going to understand both, and you will see why the second one is the lock that no clever engineer has ever been able to pick. So this is the invitation. Get comfortable, settle in, and let the rest of the world go quiet for a while. We are going to take one strange idea apart, gently, the way you might take apart an old clock just to see how the gears agree with one another. We will start with a number that almost everyone gets wrong, the so-called speed of light, and discover that it is not really the speed of light at all. We will learn why no two people in the universe can ever quite agree on what the word now means. We will build a time machine out of two ordinary radios and a stretch of empty space with no wires to the future and no flux capacitor, just motion and patience. And then we will watch as warp drives, wormholes, and ghostly particles that may not even exist all walk up to the same locked door and find it shut for the very same reason. There is an image I want you to hold on to, because we will return to it at the very end when the journey is done. Picture the speed of light, not as a wall and not as a finish line, but as a single thread, fine and strong, stretched through everything that has ever happened and everything that ever will. That thread holds the past behind you and the future ahead of you. It keeps your yesterdays from spilling into your tomorrows. And the question we are really asking tonight, underneath all the physics, is what would happen if that thread were ever cut. But before we can cut a thread, we have to understand what it is holding. And to understand that, we have to start with the most misunderstood number in all of science, a number that is not about light at all. Is less than break time equals 1s, is greater than number part 2, the speed of causality, and how light just happens to ride it. We call it the speed of light, and that name has fooled almost everyone who has ever heard it. The name makes you think the important thing in the universe is light, and that this particular speed belongs to light the way a top speed belongs to a car. But that is backward. The speed is not a property of light. Light is simply one of the things fast enough to travel at it. A better name, and the one I would like you to carry with you for the rest of the night, is the speed of causality. It is the fastest rate at which anything in the universe can affect anything else. It is the top speed of cause and effect, the absolute limit on how quickly a push, a pull, a signal, a warning, or a piece of news can cross from one place to another. Light moves at this speed for one simple reason. A particle of light, a photon, has no mass at all, and anything with no mass is obliged to travel at exactly this cosmic top speed, no faster and no slower. Light is not the king of the universe. Light is just one of the king's fastest messengers, and the throne it rides toward belongs to causality. Let me give you the number, and then let me make it something you can feel, because a number on its own is just a smudge of ink. The speed of causality is about 300,000 kilometers every second. That is so fast that in the single second it takes you to say the word causality out loud. A beam of light could circle the entire planet roughly 7.5 times. It is fast enough that when you look up at the sun, you are not seeing the sun as it is. You are seeing it as it was about 8 minutes ago, because that is how long its light has been travelling to reach your eyes. If the sun were to simply vanish, you would feel nothing, notice nothing, suspect nothing, for a full 8 minutes. The warmth on your face would be a message from a star that for all you knew no longer existed. That delay, that little 8-minute lie the sky tells us, is the speed of causality at work. Nothing about the sun's disappearance, not its light, and not even its gravity, could reach us any faster. Now, why can nothing with mass ever be pushed up to this speed? This is the first of our 2 reasons, the energy reason, and it is worth understanding clearly because it is the one most people stop at. The rule is this: the faster a massive object already moves, the more energy it takes to speed it up by even a little more. At everyday speeds, you barely notice. But as you climb toward the speed of causality, the cost of each additional sliver of speed begins to swell, and then to balloon, and then to run away from you entirely. To reach the speed of light from below, an object with mass would need not a great deal of energy, not an enormous amount of energy, but an actually infinite amount, more than exists in the entire universe. The barrier is not a wall you could break with a bigger hammer. It is a slope that gets steeper the closer you come, until it stands perfectly vertical, and no engine that could ever be built can climb a slope with no top. Something strange and wonderful happens to time as you approach this barrier, and it is worth pausing on because it is the first hint that speed and time are secretly the same subject. When an object moves very near the speed of causality, its clock slows down relative to yours. This is not an illusion and not a trick of measurement. Time genuinely runs slower for the fast traveller. At 99% of light speed, a single year aboard a ship would stretch to about 7 years back home, push closer to a whisker beneath the limit, and a single year on the ship could equal centuries outside it. A traveller could leave, feel only months pass, and return to find everyone they knew long gone, their grandchildren grown old. Time, in other words, is already bending at these speeds. It is already pliable, already negotiable, already strange. Faster than light travel is simply what happens when you bend it past the point where it can spring back. Here is the move that will matter for everything to come, so let me say it slowly and clearly. The energy barrier we just described only forbids one specific thing. It forbids crossing the speed of causality by pushing harder from below. It is a statement about brute force, about engines and fuel and acceleration. And brute force is not the only way to get somewhere. If the only barrier in our way were the energy wall, then clever tricks might still let us through. We could try to bend space itself so that we arrive early without ever locally moving fast. We could try to tunnel through to a distant place without crossing the space between. The energy wall says nothing against these schemes, because they do not involve pushing a massive object up to light speed at all. They sidestep the wall entirely. And this is exactly why there must be a second barrier, a deeper and stranger one, that the clever tricks cannot get around. Because if the only thing stopping faster than light travel were a matter of fuel, then a sufficiently inventive civilization would simply find a back door, and the universe would be full of time paradoxes, messages that cancel themselves. causes that erase their effects. The fact that the universe seems remarkably free of such contradictions tells us something. It tells us there is a guardian we have not yet met. It is worth dwelling, just for a moment, on how genuinely recent and hard-won this understanding is, because it is easy to take for granted. For most of human history, people assumed that speed had no upper limit at all, that with enough force you could always go faster, the way a horse can always be whipped to a gallop and a gallop pushed to a sprint. The notion that the universe contains an absolute ceiling, a speed beyond which nothing can ever go, no matter how hard you push, would have struck almost every thinker before the 20th century as bizarre, even offensive, and the ceiling is not arbitrary. It is not as though some cosmic committee picked a number and posted it. The limit falls out of the requirement that the speed of light look the same to everyone, the single strange fact Einstein took seriously when others waved it away. Everything else, the slowing of clocks, the shrinking of fast objects, the tilting of now, and the impassable wall at light speed, all of it follows from that one insistence. The universe decided that one speed would be the same for every observer, and in exchange it had to make space and time themselves flexible, negotiable, willing to bend. The speed limit is the price the universe pays to keep that one number sacred. And as we will see, it is a price that buys something precious in return. There is one more clue worth tucking away before we move on. Light is not the only thing that travels at this top speed. Gravity travels at exactly the same speed. So do the forces that hold the nuclei of atoms together. When two black holes spiral into each other and shudder the fabric of space-time, the ripples they send out arrive at precisely the speed of light, not a fraction faster. This is the giveaway that the speed of causality is not really about light at all. It is woven into the wiring of the universe itself, a single number that everything obeys, from a photon to a gravitational wave to the pull of a distant star. So we have our first reason, the energy wall, and we have a strong suspicion that it is not the whole story. To find the second reason, the one with no loopholes, we have to confront something Einstein discovered more than 100 years ago that still quietly unsettles people who really think about it. We have to confront the fact that no two people in this universe can ever fully agree on a single, simple word. The word is now. Is less than break time equals 1s is greater than number, part 3. Nobody agrees on now. Of all the things Einstein gave us, this is the one that gets the least attention and deserves the most, at least for our story tonight. It does not have a dramatic name. It is called the relativity of simultaneity, which is a mouthful, so let me just tell you what it means. It means that whether two events happen at the same time is not a fixed fact about the universe. It depends on who is asking and on how fast they are moving. Two flashes that you would swear happened in the same instant could, to someone gliding past you, have happened one after the other, and neither of you would be wrong. Let me build the classic picture, the one Einstein himself liked to use, because once you see it, you cannot unsee it. Imagine a long train car moving smoothly down a track, and imagine a lamp hanging at the exact center of that car. At some moment, the lamp flashes, sending light toward both ends of the car at once. Now ask a simple question. Does the light reach the front of the car and the back of the car at the same time? If you are a passenger sitting inside the train, the answer is obviously yes. You are sitting still relative to the lamp and the walls. The light has the same distance to travel in both directions. It travels at the same speed both ways, and so it strikes the front wall and the back wall in the very same instant. Simultaneous. Case closed. But now, picture someone standing on the platform, watching the train rush past. From their point of view, something different happens, and here is the part that bends the mind. While the light is travelling, the train is moving forward. The back wall of the car is rushing toward the spot where the flash happened, and the front wall is racing away from it. So the light, which travels at the same fixed speed for the platform observer too, reaches the back wall first, because the back wall came to meet it, and reaches the front wall a little later, because the front wall ran away. To the person on the platform, the two flashes are not simultaneous at all. The back one came first. Now, who is right? That is the question everyone wants to ask, and the answer is the whole revolution in a single word. Both. They are both right. There is no secret third referee standing outside the universe who can tell us the true order. Simultaneity, the sense that two distant things happen at the same moment, is not a property of the events themselves. It is a property of the observer, and it tilts depending on how that observer moves. The word now, stretched across any real distance, is not a single shared instant that all of creation agrees on. It is more like a line that each observer draws at a slightly different angle through the fabric of time. I can feel the unease this produces, so let me reassure you immediately, because the reassurance is the most important part. This disagreement about order is not total chaos. It is fenced in by a strict and merciful rule. Two events can only have their order disputed if they are far enough apart in space that not even light could have travelled from one to the other in the time between them. Only then is their order up for grabs. For any two events close enough together that a beam of light, or anything slower, could pass between them, every observer in the universe agrees, without exception, on which one came first. Sit with how comforting that is. It means that for anything that could possibly be cause and effect, for the lightning and the thunder, for the push and the fall, for the question and the answer, the order is absolute. Everyone everywhere, no matter how fast they move, sees the cause come before the effect. The universe has built itself a safety margin, a buffer zone, and the size of that buffer is set precisely by the speed of causality. As long as nothing outruns light, cause stays before effect for every single observer who has ever existed or ever will. The order of the story is safe. I find it helps to think about why the buffer is exactly the size it is, because it reveals how carefully the whole arrangement is balanced. The reason observers can disagree about the order of two distant flashes is that the news of one flash, travelling at the speed of light, has not yet had time to reach the place where the other flash happened. In that gap, in that window, before the news can arrive, the two events are causally disconnected, strangers to each other, and so different observers are free to disagree about which came first, because no influence has passed between them to settle the matter. But the moment the two events are close enough that light could carry a signal from one to the other, they stop being strangers. Now one could be the cause of the other, and the universe will not tolerate any observer seeing an effect arrive before its cause. So the buffer is not a coincidence, and not a safety feature bolted on afterward. It is the same fact, viewed from two sides. Events that light can connect are events whose order is fixed. Events that light cannot connect are events whose order is free. And faster than light travel is precisely the act of forging a connection across the gap that was supposed to keep two events, strangers, dragging into the realm of cause and effect a pair of events whose order was never meant to be pinned down. And now you can perhaps feel the trap closing gently, the way a good story closes its trap, because what is faster than light travel, really, in the language we have just built? It is precisely the act of connecting two events that are too far apart for light to bridge. It is sending a signal into that fenced-off region where the order of events is no longer something everyone agrees on. Faster than light travel does not nudge the rules a little. It walks straight into the one and only zone in the entire universe where before and after stop being fixed, the one place where the order of time itself is negotiable. Let me give you an image to carry. Think of all the different observers in the universe, each one holding their own sense of now, like a card held at a slight tilt. For ordinary, slower-than-light events, all the cards point the same way, and everyone agrees on the sequence. But an event reached only by faster-than-light travel is a strange card, one that can slide to the wrong side of the deck depending on who is holding it. For one observer, it lands in the future. For another, moving differently, it lands in the past. The event refuses to hold still in time, so we have found the shape of the danger. We know that outrunning light means entering the region where order dissolves. But knowing the danger exists is not the same as seeing exactly how it bites. To watch the order of cause and effect actually flip, to see a before become an after with your own eyes, we need to draw the true shape of cause and effect in this universe. And it turns out that shape is not a line and not a wall. It is a cone. Is less than break time equals 1s. Is greater than number part 4. The shape of cause and effect. A few years after Einstein published his idea, a mathematician named Hermann Minkowski looked at it and saw something Einstein himself had not quite seen. Minkowski realized that space and time were not two separate things, a stage and a clock, but a single woven fabric, 4 dimensions stitched together into one continuous whole. He called it space-time, and he said something that has been quoted ever since, that from then on space by itself and time by itself were destined to fade into mere shadows, and only a kind of union of the two would keep any independent reality. It sounds grand, but what he meant is simple and useful. Every event that has ever happened, every flash and footstep and heartbeat, is a single point in this 4-dimensional fabric, marked by where it happened and when. Once you picture events as points in space-time, you can ask which points can reach which other points, and the answer draws a shape. Picture an event, any event, a candle being lit in a dark room. From that instant, the candle's light spreads outward in all directions, a growing sphere racing away at the speed of causality. If you track that expanding sphere not just across space but across time as well, drawing time as an upward direction on a diagram, the sphere traces out the surface of a cone, opening upward into the future. Physicists call it the light cone, and it is one of the most important shapes in all of science. The cone has 2 halves. The upward half is the future light cone, and it contains every event the candle could possibly influence, everything its light, or anything slower than its light, could ever reach. The downward half, opening into the past, contains every event that could possibly have influenced the candle, everything whose light could have arrived in time to matter. And then there is everything else, the enormous region outside the cone entirely, neither future nor past, but a kind of cosmic elsewhere, made of all the events too far away in space to be reached from the candle at light speed or below. This gives us a clean way to talk about cause and effect. When 2 events lie inside each other's cones, when one sits in the future cone of the other, physicists say they are time-like separated. This is the realm of cause and effect. A signal can pass between them at or below the speed of light, and crucially, every observer in the universe agrees on their order. The cause is in the past cone, the effect is in the future cone, and no amount of motion can swap them. The 2 events are locked into their sequence. But when 2 events lie outside each other's cones, out in that region of cosmic elsewhere, physicists say they are space-like separated. No signal, at light speed or below, can connect them. They are too far apart in space for the time between them. And for these events, and only these events, the order is not fixed. Remember the train and the platform. Depending on how an observer moves, one of these events can come first, or the other can, or they can be simultaneous. Their sequence is negotiable, exactly as we found in the last part. Now hold the cone in your mind and watch what faster-than-light travel actually does to it. A path that stays slower than light always stays inside the cone, climbing up through the future, staying safely in the land of fixed order. But a faster-than-light path is a line that leans over so far that it leaves the cone entirely and crosses out into the elsewhere. By its very definition, a faster-than-light journey is a journey into the region where time order is not settled. It is not that faster-than-light travel might cause a problem with time. It is that faster-than-light travel is, geometrically, the act of stepping into the only place where the problem lives. There is one more piece, and I will keep it gentle because you do not need the mathematics to feel the truth of it. Even though different observers disagree about times and distances, they all agree on one combined quantity, a particular way of weaving the time between two events together with the distance between them. Physicists call it the interval, and it is the same for everyone, a rare island of agreement in a sea of disagreement. And here is the quiet, devastating thing. It is precisely this universal agreement on the interval that guarantees the disagreement on order. The very rule that keeps the universe consistent for slower-than-light events is the same rule that, for a faster-than-light event, mathematically forces the existence of some observer who sees the traveller arrive before they left. The arrival in the past is not a glitch or an approximation. It is required by the same machinery that makes everything else hang together. There is a way to feel this in your own body, right now, without any mathematics at all. Everything you can currently affect, every object you could reach out and touch, every person you could call, every place a letter from you could eventually arrive, all of it lies inside your future light cone, the upward opening part. Everything that has shaped you, every word you have heard, every photon that has entered your eyes, every cause that has rippled forward to make this moment what it is. All of that lies inside your past light cone, the downward part. And then there is the rest of the universe, the present moment of a galaxy 1 billion light years away, the surface of a star whose light will not reach you for centuries, all of it sitting in your elsewhere, the region you can neither touch nor be touched by. Not now, not at this instant. You are, at every moment of your life, sitting at the tip of two cones, one reaching back to gather everything that made you, and one reaching forward to hold everything you might yet change. To travel faster than light would be to step sideways, out of both cones, into the elsewhere, into the one place where the tidy division between what made you and what you might make breaks down completely. You do not need to hold the equations. You need to hold the picture. Inside the cone, time flows in one direction, and everyone agrees. Outside the cone, direction itself becomes a matter of opinion. And faster-than-light travel is the single act that carries you across that boundary, out of the land of settled time and into the elsewhere, where before and after lose their meaning. Every step of our journey tonight, every warp drive and wormhole and ghostly particle still to come, is really about this one question. What happens when you step outside the cone? We have the geometry now. We have the stage. So let us finally do the thing the title promised. Let us build a time machine. And the astonishing part, the part I still find hard to believe even knowing it is true, is that we will not need anything exotic to do it. No wormhole, no warp bubble, no strange matter from the dawn of creation. We will need only 2 ordinary radios, 2 ordinary people, and a stretch of empty space between them. Is less than break time equals 1s. Is greater than number, part 5. 2 radios and a stretch of empty space. The idea we are about to build has a wonderful and slightly absurd name. It is called the tachyonic anti-telephone. The physicist Richard Tolman first sketched it out around 1917, and the strange name was attached later, in 1970, by 3 physicists named Benford, Book, and Newcomb. The name is a joke, really. A telephone lets you talk to someone far away in space. An anti-telephone, they suggested, would let you talk to someone far away in time, to your own past, for instance. And the unsettling thing they proved is that if you can send signals faster than light, you have already built one, whether you meant to or not. Let me introduce two characters, because this is easier to feel with people than with abstractions. We will call them Alice and Bob, as physicists always do. Alice is on one ship, Bob is on another, and the two ships are drifting apart at high speed, a good fraction of the speed of light, but comfortably below it. Nothing illegal yet. They are just two travellers moving apart, the way two cars pull away from each other on a long, straight road, and each of them carries a transmitter that can send a signal faster than light. Not infinitely fast, just faster than light. We are granting them that one magic power and nothing else to see what it costs. Step 1. Alice decides to send Bob a message. She points her faster-than-light transmitter at Bob's ship and fires. From Alice's point of view, sitting in her own ship, perfectly still as far as she is concerned, the message races out and forward in time and arrives at Bob's ship a little while later. Completely normal. The message went out, then it arrived. Cause before effect. Alice sees nothing strange at all. Step 2. Bob receives Alice's message, reads it, and decides to reply. He points his own faster-than-light transmitter back at Alice and fires. And from Bob's point of view, sitting still in his own ship, his reply also races out and forward in time and heads back toward Alice. Bob, too, sees nothing strange. His message went out, and it will arrive. Cause before effect, just as it should be. So each of them, in their own ship, did something that looked perfectly ordinary. Alice sent forward in time. Bob replied, forward in time. Neither of them broke a rule that they could see. And yet, watch what the universe actually does with these two perfectly ordinary acts. Because Alice and Bob are moving relative to each other, their senses of now are tilted at different angles, exactly as we learned with the train and the platform. Bob's idea of forward in time is leaning, from Alice's perspective, in a direction that points partly into Alice's past. And when you combine Alice's faster-than-light send with Bob's faster-than-light reply, the two tilts stack on top of each other, and the reply does not simply come back a little later. It comes back before Alice ever sent her original message. Bob's answer arrives in Alice's past. I want to slow all the way down here because this is the keystone of the entire video, the single most important thing we will say tonight. Read it again in your mind. Alice sent a message forward in time. Bob replied forward in time, and the reply landed in Alice's past. Two perfectly forward steps, taken by two people who never agreed on which way now was tilted, added up to a step backward through time. Faster than light, taken twice, became earlier than the beginning. The phrase, faster than light, has quietly, while we were not looking, turned into the phrase, backward in time. They are the same act. They were always the same act. You might wonder how fast the signals have to be, and how fast the ships have to move for this to happen, and the answer has a lovely simplicity to it that is worth feeling even without the equations. The faster Alice and Bob move apart, the more their senses of now tilt, and so the less faster than light you actually need to reach into the past. There is a clean threshold buried in the mathematics. Roughly speaking, once the speed of the ships, multiplied by the speed of the signal, climbs past the speed of light multiplied by itself, the loop into the past opens. What that means in plain language is almost funny. If your ships are moving fast enough, you barely need to break the light barrier at all. A signal just a hair faster than light, in the hands of two fast-moving observers, is already enough to start prying open yesterday. Let me put a real number against that, just to make the delicacy of it land. There was once an experiment, and we will tell its full story later tonight, that seemed to catch particles arriving about 60 nanoseconds early. 60 nanoseconds is the time it takes light to cross about 18 meters, the length of a modest swimming pool. That is the entire size of the head start we are talking about. A sliver of time so thin you could not blink inside it. And yet a head start that's small, exploited by clever observers moving fast enough, is in principle enough to begin reaching backward through time. The barrier between forward and backward is not some massive gate. It is a thread, fine as spider silk, and the anti-telephone shows us exactly how to cut it. Let me linger on the deepest source of the trouble, because it is so easy to slide past and so worth holding on to. The whole thing turns on the fact that Alice and Bob disagree about which way forward in time points. To Alice, her own forward is obvious and absolute. To Bob, his own forward is equally obvious and absolute. Neither is making a mistake. The trouble is only that their two forwards are tilted with respect to each other, and a faster-than-light signal is the one kind of signal sensitive enough to that tilt to be carried by it into the past. A slower-than-light signal is too sluggish to feel the tilt. It stays safely inside the light cone no matter whose forward you measure it against, and so it always arrives after it left for everyone. But a faster-than-light signal rides right along the edge where the tilt matters, and the tilt is enough to flip it over. This is why the speed of light, and not some other speed, is the magic threshold. It is exactly the speed at which the disagreement about now stops being harmless and starts being dangerous. Below it, the disagreement is real but toothless. At it, and beyond, the disagreement grows teeth, and the teeth bite into the order of time itself. And notice, please notice, what we did not need. We did not need a wormhole. We did not need exotic matter scraped from the edge of a black hole. We did not need a machine with a glowing core and a countdown timer. We needed 2 radios and 2 travelers and a single granted power, the power to outrun light. That power alone, with nothing else added, is a time machine. This is why physicists take the speed limit so seriously, and why they get so nervous whenever an experiment seems to violate it. It is not the speed they fear. It is the time machine that comes free with the speed, whether you ordered it or not. So we have a reply that arrives before its question. That is strange, certainly, strange enough to keep you up at night. But strange is not the same as impossible. A message landing in the past is a paradox waiting to happen, not yet a paradox itself. To turn this strangeness into a true contradiction, into a knot the universe genuinely cannot tie, Alice has to do just one more small and very clever thing. And it is the same trick we met in the very first minutes of tonight's journey. Is less than break time equals 1s, is greater than number, part 6. The grandfather paradox in radio waves. Here is the one small thing Alice does. She wires a rule into her transmitter, the same rule we met at the very beginning. The rule says, only send the original message if no reply has already arrived. That is all. It is a sensible, almost boring instruction. Do not bother asking a question that has already been answered. Any careful engineer might add it without a second thought. But follow the rule around the loop we just built, slowly, and watch it eat itself. Suppose Alice sends her message. Then, as we established, Bob's faster-than-light reply comes racing back into Alice's past, and the reply arrives before she sent. So by the time her transmitter is deciding whether to fire, the reply is already sitting in her receiver. And the rule says, clearly, if a reply has already arrived, do not send. So, she does not send. But if she does not send, then Bob never receives anything, and so Bob never replies, and so no reply ever arrives in Alice's receiver. And the rule says, just as clearly, if no reply has arrived, send. So, she sends. Go around again, and you find the same trap perfectly closed. If she sends, the rule forbids her from sending. If she does not send, the rule commands her to send. The message goes out if and only if it does not go out. There is no answer the universe can give that does not contradict itself. It is not that we do not know whether Alice sends. It is that there is no consistent fact of the matter at all. We have asked the universe to make a single statement, both true and false in the same breath. You have met this knot before. though dressed in older clothes. It is the grandfather paradox. The classic version goes like this. A man travels back in time and, whether by accident or design, prevents his own grandparents from ever meeting. So his parent is never born. So he is never born. So he never grows up to build the time machine, never makes the trip, never prevents the meeting, and so his grandparents do meet after all, and he is born after all, and back around it goes, forever, with no stable answer. The story is usually told with a sense of menace, with murder and family trees and dramatic music. But strip all the drama away, and what is left is exactly Alice's radio. A cause that erases its own effect. An action that undoes its own reason for happening. The grandfather paradox is not really about grandfathers. It is about information travelling into its own past and forbidding itself. I want to be careful and fair here, because physics has tried hard to wriggle out of this, and you deserve to know about the wriggle. Some physicists noticed that if you forget about people making choices and just look at a lone particle travelling backward in time, you can sometimes redescribe it cleverly. A particle that looks like it is going backward in time, carrying negative energy, can be relabeled as an ordinary particle going forward in time the other way. This relabeling trick is called the reinterpretation principle, and for a single, mindless particle, it genuinely smooths things over. The contradiction seems to dissolve into a matter of bookkeeping, but the trick has a fatal limit, and the limit is the very thing that makes us human. The moment you put a decision into the loop, the moment someone like Alice gets to choose whether to send based on what she has received, the relabeling fails completely. You cannot relabel a choice away. A free agent who can say yes or no, who can wire in a rule like only send if no reply has come, breaks the bookkeeping and drags the full contradiction right back into the open. So the escape works only for things that cannot decide, and fails for everything that can. The universe, it seems, is safe from paradox only as long as no one with a will and a transmitter ever outruns light. It is worth pausing to feel the full weight of what this means for the dream of faster-than-light travel, the dream that has powered 1,000 stories. We tend to imagine the speed limit as a frustration, a cruel inconvenience standing between us and the stars, the reason a voyage to even the nearest star would outlast a human lifetime many times over. We imagine that if only we were clever enough, or built engines powerful enough, we could brush the limit aside and finally go exploring. But what the radio paradox reveals is that the limit is not standing between us and the stars out of mere stinginess. It is standing between us and a contradiction. The same wall that keeps us slow is the wall that keeps the universe consistent. You cannot tear down one without tearing down the other. To gain the freedom to outrun light would be to lose the guarantee that effects follow causes, that questions precede answers, that the world makes sense in a single agreed-upon order. And that is a far steeper price than fuel or patience or engineering. It is the price of coherence itself. So let me say the strongest version of our central claim now, plainly, because we have earned it. Faster than light travel, all by itself, with no machinery beyond a way to send signals and a person willing to make a choice, is already a time machine. And every time machine, the moment you can carry controllable information into your own past, opens the door to a contradiction the universe appears completely unwilling to allow. The speed limit and the ban on time paradoxes are not two separate laws that happen to sit near each other. They are one single law seen from two different angles. To forbid the paradox, you must forbid the faster-than-light signal. To allow the signal, you must allow the paradox. There is no third option, which leaves us standing in front of a genuinely open question, and it is the question that powers the entire second half of our night. If outrunning light leads straight to logical impossibility, then what does the universe actually do about it? Does it simply forbid faster-than-light travel outright, slam the door, end of story? Or are there backdoors? Are there clever ways to arrive somewhere early, to beat a beam of light from one star to another, without ever locally outrunning light in your own little patch of space, and so perhaps without triggering the paradox at all? For most of the last century, the brightest minds in physics have gone looking for exactly those backdoors. Tonight, we are going to walk through 3 of them. And the strange, almost eerie thing we will find is that every single one of them, no matter how clever, leads us right back to the same locked door. Is less than break time equals 1s is greater than number, part 7, bending space instead of crossing it. The smartest objection to everything we have said so far goes like this. You told us we cannot cross the speed limit by pushing harder because of the energy wall. Fine. So do not push at all. Do not try to move your ship quickly through space. Instead, move the space. If you could somehow grab the fabric of the universe itself and pull it past your ship could sit perfectly still in its own little pocket and still arrive across the galaxy faster than a beam of light could make the trip the ordinary way. You would never locally break the speed limit. You would let the universe do the running. This is not idle dreaming. In 1994, a physicist named Miguel Alcubierre took that exact objection and wrote it down as real mathematics, real solutions to Einstein's equations of gravity. The idea is now called the Alcubierre drive, or simply the warp drive, and it works like this. You contract the space directly in front of your ship, squeezing it together, while you expand the space directly behind, stretching it out. Your ship rides in a flat, calm bubble in the middle, like a surfer carried along by a wave that the surfer is not actually swimming to keep up with. Inside the bubble, the crew feels nothing. They are not accelerating. They are not moving fast through their local space at all. But the bubble itself, the wave, carries them between stars faster than light could travel the same road. From the outside, the ship has crossed the galaxy in a flash. From the inside, it never broke a single local rule. It is a genuinely beautiful idea, and it solves the energy wall completely because the ship never tries to climb that runaway slope of speed. But it comes with a price, and the price is severe. To squeeze space in front and stretch it behind, the warp drive requires a substance that does not seem to exist, something with negative energy, a kind of matter that gravitates in reverse, pushing instead of pulling. Physicists call it exotic matter, and we have never found it in any usable amount. Worse, the early calculations said you would need an absurd quantity of it. The amount of negative energy to wrap a ship in a warp bubble came out comparable to the total mass energy of the planet Jupiter, converted entirely into this strange reversed stuff. It was, to put it mildly, not an engineering project for next year. But here is where it gets interesting, because the warp drive is not dead and the last few years have seen real progress. A physicist named Harold White, who has worked on these ideas at NASA, suggested that by reshaping the bubble, by changing the geometry of that ring of negative energy, the staggering requirement might be slashed enormously, perhaps from the mass of a planet down to something far smaller. In 2021, 2 researchers named Bobrick and Martier published a broad new framework, showing that there is not just one warp drive but a whole family of them, many different shapes, that all carry a bubble through space. They even showed that some warp drives, the ones that stay slower than light, could in principle be built with ordinary positive energy, no exotic matter required at all. Around the same time, a physicist named Eric Lentz found warp solutions built from special, self-reinforcing waves, again using only positive energy. And the work has continued right up to the present, with newer designs exploring more practical, more buildable shapes, including geometries that replace the smooth ring with a set of separate structures, almost like the engine pods on a starship from television. It would be easy, reading the recent headlines, to think the warp drive is nearly within reach. But notice exactly what all this progress has done, and exactly what it has not done. Every one of these advances chips away at the energy problem. They make the bubble cheaper, the matter more ordinary, the geometry more sensible, and not one of them touches the other problem, the time problem, the one we built so carefully in the first half of tonight. Because the moment a warp bubble actually carries you faster than light, it lands you out in that region of cosmic elsewhere, the place where the order of events is up for grabs. And two warp ships, or even one warp ship plus some ordinary relative motion, can be combined in exactly the way Alice and Bob combined their radios. The reply can arrive before the message. In fact, physicists worked this out in the late 1990s. Allen, Everett, and others showed, with full mathematical rigor, that Alcubierre warp drives can be assembled into time machines. Build two of them, route them cleverly, and you have an anti-telephone made of bent space instead of radio waves. I want to be fair to the warp drive because it is genuinely one of the most creative ideas in modern physics, and the people working on it are not cranks. They are serious researchers chasing a real possibility, and the slower-than-light versions of their work may someday teach us things about gravity and energy that have nothing to do with time travel at all. But there is a habit in the way these stories reach the public that I want to gently correct, because it matters. When a new warp drive paper appears, the headlines almost always say something like, "Faster than light travel may be closer than we thought," and they almost never mention the time travel problem at all. They talk about the energy, because the energy is the part that sounds like an engineering challenge, the kind of thing a clever team might solve. The causality problem gets left out, because it does not sound like a challenge. It sounds like a wall. And it is a wall, the same wall we have been describing all night, the one that does not care how clever you are. So when you read that we are closing in on a warp drive, the honest footnote, the one rarely printed, is this: we may be closing in on the energy. We are no closer at all to escaping the paradox, because the paradox was never an engineering problem to begin with, so the warp drive is not really a loophole at all. It is the same trap in a more elegant costume, and this is the thing I most want you to carry away from this part, because it tells us something about the universe and not just about one invention. The paradox we built is not a property of radios or of any particular machine. It is a property of faster-than-light travel itself, no matter how you achieve it. Change the vehicle all you like. Trade the rocket for a warp bubble, trade brute force for bent space. The locked door appears again in the same place for the same reason. The universe does not care whether you outran light by pushing or by surfing. It only cares that you outran light, and that is the one thing it will not abide. The warp drive tries to cheat the speed limit by bending space around the journey, but there is another way to cheat distance, an even more audacious one. Instead of bending the space you travel through, what if you simply refused to travel through it at all? What if you punched a hole, a tunnel, straight from here to there, and stepped through? That is the wormhole, and it makes the connection between faster-than-light travel and time travel more naked than anything we have seen yet. Is less than break time equals 1s is greater than number part 8. The shortcut that becomes a tunnel into yesterday, the warp drive moved the space around the journey. The wormhole takes a more radical view. It says, why travel the distance at all? If two places are far apart on the surface, perhaps they can be brought close together through a hidden tunnel underneath. Picture a sheet of paper with two dots on opposite ends. The ordinary way to get from one dot to the other is to crawl across the whole sheet. But fold the paper so the two dots touch, punch a tunnel through the fold, and you can step from one to the other directly, ignoring all the distance in between. A wormhole is that tunnel made of space-time itself. In 1988, the physicist Kip Thorne, along with his colleagues Michael Morris and Ulvi Yurtsever, did something important. They asked whether such a tunnel could be made not just to exist, but to be safely traversable, something a human being could actually pass through without being torn apart. And they found that the equations allowed it, with one familiar catch. To hold the throat of the wormhole open, to keep it from pinching shut in an instant, you would again need exotic matter, that same strange substance with negative energy that the warp drive demanded. So once more, we are in the realm of the theoretically permitted but practically unbuilt. No one has ever found a wormhole, and no one has ever made one. But the equations do not forbid them, and that is enough for our purposes tonight, because we are hunting for the principle, not the blueprint. Now here is where Thorne did something that should make the hair on your arms stand up. He showed, in plain steps, how to turn any traversable wormhole into a time machine. And the recipe uses nothing more than ideas we have already met. Take a wormhole with two mouths, two openings, like two doors that lead to the same hidden tunnel. Leave one door at home. Take the other door, load it onto a ship, and fly it out into space at close to the speed of light, then bring it back. We learnt earlier what high-speed travel does to time. The travelling door, like any fast traveller, ages more slowly than the one that stayed home. When the journey ends, the two doors no longer agree on what time it is. One of them is, quite literally, younger than the other. And now comes the strange and lovely part. Because the two doors are connected through the tunnel, stepping through the wormhole does not just move you across space, it moves you across the time difference between the mouths. Walk in through the younger door, and you come out the older one, and you have stepped into the future. Walk in through the older door, and you come out the younger one, and you have stepped into the past. Once the age gap between the two mouths grows larger than the time it would take light to travel between them the ordinary way, the wormhole becomes a genuine passage backward through time. Two identical doors in a room, except that one has been kept young while the other grew old, and walking through the right one drops you into yesterday. There is something worth noticing about this recipe that makes it even stranger than it first appears. Nothing in it requires you to travel faster than light in the moment you step through. Walking through a doorway is the gentlest thing imaginable. You could stroll through, coffee in hand, at a leisurely pace, and still come out the other side a year in the past. All the faster-than-light part, all the cheating of distance, happened earlier, quietly, when the wormhole was first made and one of its mouths was sent on its high-speed trip. By the time you arrive to use it, the time machine is just sitting there, finished, harmless-looking, waiting. And this is exactly why a wormhole shortcut and a wormhole time machine cannot be separated. The very thing that makes the tunnel a shortcut, the fact that it connects two distant places more quickly than light could travel between them the long way, is the same thing that lets a small difference in the ages of its two mouths become a doorway into the past. You cannot build the helpful version, the convenient cosmic subway, without also building the dangerous version, the passage backward through time. They are not two features of the wormhole. They are one feature wearing two faces. Picture standing in that room. The two doors look the same. They feel the same. There is nothing about either of them that announces its danger. And yet one of them opens onto last week or last year. And if you carry a message through it, you can hand that message to someone before they ever sent the question it answers. You can build the anti-telephone again, this time out of doors and tunnels instead of radios or warp bubbles. And of course, with the message in the past, you can add Alice's little rule, only send if no reply has come, and the whole grandfather paradox snaps shut around you exactly as before. This is why the wormhole matters so much to our story, more even than the warp drive. It strips away every disguise and shows the equivalents completely naked. A wormhole that lets you beat a beam of light from one star to another is, with one ordinary step, with nothing more than a round trip and some patience, a wormhole into the past. Faster-than-light shortcut and backward time machine are not two different things that happen to be related. They are one and the same object, looked at from two angles. The tunnel that saves you distance is the tunnel that costs you the order of time. You cannot have one without the other, because they were never two things to begin with. And so the wormhole delivers us right back to the central truth of the night, the one the radios first showed us. To arrive faster than light and to arrive in the past are the same arrival. The universe does not distinguish between them, because in its geometry there is no distinction to draw. Whether you bend space, or tunnel through it, or simply send a signal across it, the instant you outrun light you have stepped into the elsewhere, and the elsewhere does not keep its before and after in any fixed order. But ships and tunnels are enormous, dramatic things, the stuff of starfleets and engineering on the scale of planets. Let me bring the question down to its smallest possible form, because the smallest form is in some ways the most haunting. Forget the ship. Forget the wormhole. What if a single particle, something tiny, something that might be passing through this very room right now, were already breaking the rule? What if the universe contained, woven into its quietest corners, a kind of matter that is born moving faster than light and can never slow down? That is the tachyon, and for a few electric weeks, more than a decade ago, the world believed one had finally been caught. His less than break time equals 1s. His greater than. Number part 9. The particle that is born too fast. Up to now, we have been imagining ways to push something across the light barrier from below, or to sneak around it. But there is a different question hiding underneath all of them, the purest version of the whole problem. Forget pushing, forget sneaking. Could there simply exist, as a natural part of the universe, a particle that is always on the far side of the barrier? Something that has never been slower than light, not for an instant, that was born fast and stays fast. Because if such a particle existed, and if we could control it, we would not need to build anything at all. We would have the anti-telephone handed to us by nature, and the past would be a phone call away. Physicists gave this hypothetical particle a name in the 1960s. They called it the tachyon, from a Greek word for swift. The groundwork was laid by physicists named Belaniuk and Sudarshan, and the particle was given its name by Gerald Feinberg in 1967. And the tachyon is one of the strangest objects ever to appear in serious physics, because everything about it runs in reverse compared to ordinary matter. Consider how an ordinary particle behaves. The more energy you pour into it, the faster it goes, climbing toward the speed of light, but never reaching it. The tachyon does the opposite. The more energy it has, the slower it goes, creeping down toward the speed of light from above, but never reaching it from that side either. And as a tachyon loses energy, it speeds up, racing toward infinite speed as its energy drains away toward nothing. The speed of light is still the barrier, still the line that cannot be touched, but the tachyon lives on the wrong side of it, mirror image to everything we know. Strangest of all, the mathematics says a tachyon would have an imaginary mass measured by a number that, when multiplied by itself, gives a negative result. That is not a quantity you can ever weigh on a scale. It is a flag, the equations wave to tell you that you are dealing with something that does not sit still, something that cannot be brought to rest, because rest, for a tachyon, would mean infinite speed. Now, we must come back to the rule we learned with Alice and Bob, because the tachyon is simply the anti-telephone shrunk down to a single particle. If tachyons are real, and if you could send and receive them at will, then you could signal faster than light, and we have already proven, carefully, that faster than light signaling is backward in time signaling, and backward in time signaling builds the grandfather paradox. The tachyon is not a separate puzzle. It is the same puzzle made of one particle instead of two ships. And physicists tried the same escape, the reinterpretation trick, redescribing a tachyon that seems to go backward in time as one going forward the other way. For a lone, uncontrolled tachyon, the trick patches things over. But the moment you try to use the tachyon to send a real, chosen message, the patch tears open and the contradiction returns, exactly as it did before. A particle you cannot control cannot make a paradox. A particle you can control can make nothing else. There is a subtlety here that most people never hear, and it is worth a moment because it changes how you should feel when you encounter the word tachyon in the wild. In modern physics, when a theorist says a field is tachyonic, they almost never mean there is a real faster-than-light bullet flying around. They mean something more abstract and less alarming. They mean the system is unstable, perched like a ball balanced on the very top of a hill, ready to roll. The famous example is the Higgs field, the thing that gives particles their mass. In the first instance, after the beginning of the universe, the Higgs field is described as tachyonic, not because anything was outrunning light, but because the field was sitting on a hilltop and about to roll down into the stable valley it occupies today. So the scary word, in practice, usually points to instability, to a ball about to roll, not to a messenger from the future. It is a humbler and stranger meaning than the science fiction version, and a good reminder that nature's vocabulary does not always match our fears. It is worth sitting with just how upside down a tachyon's life would be, because the strangeness is not a side detail, it is a clue. For ordinary matter, the lowest energy, most restful state is to sit still, and it takes enormous effort to get moving fast. For a tachyon, there is no sitting still at all. Its most restful state, the place it would settle if you drained away all its energy, is infinite speed, moving so fast it is everywhere along its path at once. To slow a tachyon down toward the speed of light, you would have to pour energy into it without limit, the exact mirror of how we must pour energy into ordinary matter to speed it up toward the speed of light. The two kinds of matter approach the same barrier from opposite sides, like two climbers on either face of an infinitely tall mountain, neither able to reach the summit, neither able to cross to the other's slope. And that image is the whole reason the energy wall, on its own, cannot forbid the tachyon. The tachyon was never trying to climb up through the barrier from below. It was born above it. The energy argument has nothing to say to a particle that never had to make the crossing. Only the causality argument, the time argument, reaches all the way up to the tachyon and tells it no. So why do most physicists doubt that real, controllable, signal-carrying tachyons exist? The answer is the most elegant thing in this whole section, and it ties the bow on everything. They doubt tachyons exist precisely because tachyons would let you telephone your own past, and telephoning your own past builds a contradiction the universe has never once been caught permitting. The suspected non-existence of the tachyon is not a separate fact about particle physics. It is the universe defending the order of cause and effect, the same defense we have seen at every turn tonight. Whether the tachyon is forbidden outright, or simply never happens to exist, or exists but can never be controlled, the result is the same. No controllable faster-than-light signal, no paradox. The locked door, again. But doubt is one thing, and evidence is another, and for a few unforgettable weeks in the autumn of 2011, it looked as though the doubt might be wrong. A real experiment, run by serious people with serious equipment, announced that it had clocked particles arriving from one laboratory to another faster than light should allow. The particles were neutrinos, the faintest and most slippery things in all of physics, and the head start was that sliver of 60 nanoseconds we mentioned earlier. The announcement set the whole world of physics on fire, because if it were true, the thread holding before and after in place had just been cut. Let me tell you what happened. Is less than break time equals 1s. Is greater than number, part 10, 60 nanoseconds, and the night the neutrinos seemed to win. The experiment was called Opera, and the setup was grand in the quiet way that big physics often is. At the laboratory at CERN, on the border of Switzerland and France, scientists fired a beam of neutrinos through the Earth itself, aiming at a detector buried under a mountain in Italy, at a place called Gran Sasso, about 730 kilometers away. Neutrinos barely interact with anything, so sending them straight through the rock of the planet is no trouble at all. The plan was simply to measure, very precisely, how long the journey took, and compare it to how long light would take to cover the same distance. In September of 2011, the Opera team announced their result, and they announced it carefully, almost nervously, because they did not quite believe it themselves. The neutrinos, they reported, had arrived about 60 nanoseconds early. Not late, not on time, early. They appeared to have crossed the distance faster than light could have, beating the cosmic speed limit by about 1 part in 40,000. It is a tiny margin, but in physics, when the thing you are measuring is the speed of causality itself, a tiny margin is an earthquake. I want you to feel why the physics community reacted the way it did, because it tells you everything about how seriously these ideas are taken. The reaction was not delight. It was dread, mixed with hard-edged skepticism, because everyone in that field understood immediately what faster-than-light neutrinos would mean. They would mean the anti-telephone is real. They would mean that, in principle, you could arrange neutrino senders and receivers in motion and deliver a message into the past, and from there build the self-cancelling loop, the cause that erases its effect. Faster-than-light neutrinos would not be a fun new particle trick. They would be a crack running straight through the order of time, and through that crack, the grandfather paradox would come pouring in. The stakes were not a Nobel Prize. The stakes were whether before still reliably came before, after, and there was a powerful piece of evidence already sitting on the table, waiting, that argued the neutrinos could not really be faster than light. Back in 1987, a star exploded in a neighboring galaxy, an event astronomers call supernova 1987A, about 168,000 light-years away. That explosion sent out both light and a flood of neutrinos. And here on Earth, the neutrinos and the light arrived at essentially the same time, within hours of each other, after a journey of 168,000 years. Now think about what that means. If neutrinos truly travelled even slightly faster than light, as Opera seemed to suggest, then over a journey of 168,000 years, that head start would have piled up and up until the neutrinos arrived, not hours ahead of the light, but years ahead, decades ahead. They did not. They arrived together. The supernova had already whispered, across 168,000 years, that neutrinos keep pace with light and do not outrun it. The Opera result was at war with the sky itself. There is a human side to this story that I think is worth telling, because it shows what scientific honesty actually looks like under pressure. The Opera team did not hold a triumphant press conference declaring that Einstein was wrong. They did the opposite. They published their result essentially as a plea, saying in effect, "We have measured something we do not believe. We have checked it as carefully as we know how, and we cannot find our mistake, so we are showing it to the entire world and asking you to find the error we surely made." That takes a particular kind of courage, the courage to risk looking foolish in public rather than to quietly bury an uncomfortable number. And the world responded in kind. Physicists everywhere pored over the experiment, proposed dozens of possible explanations, and waited. They waited because of the supernova, because of the anti-telephone, because everything they knew told them that a faster-than-light neutrino would bring the order of time crashing down, and extraordinary destruction demands extraordinary evidence. The whole episode is sometimes told as an embarrassment for science, a false alarm. I think that is exactly backward. It was science at its finest, a result no one wanted, examined without flinching, and corrected without ego. So, What was the answer? The answer, when it came in 2012, was both deflating and quietly reassuring, and it is one of the great quiet lessons in all of science. The faster-than-light neutrinos were not faster than light. The 60 nanoseconds came from a mistake in the equipment. Specifically, a fiber optic cable, the kind that carries timing signals, had not been screwed in tightly enough, and that loose connection, together with a small error in a clock, had thrown off the measurement by just enough to fake a head start. They tightened the cable, they corrected the timing, and the neutrinos fell right back into line, travelling at or just a hair under the speed of light, exactly as the supernova had promised. The universe had not broken. A cable had simply been loose. Sit for a moment with how that whole episode unfolded, because it is the scientific method working exactly as it should, and it tells us how fiercely physics guards this particular border. An extraordinary claim was made. It was not laughed off, but it was not believed either. It was checked and rechecked, and torn apart by hundreds of people around the world, until the flaw was found in a place as humble as a cable that needed tightening. The reason it received such relentless scrutiny is precisely the reason we have been circling all night. The cost of a real faster-than-light particle is not a small revision to the textbooks. It is the collapse of cause and effect. So physics treats every hint of it the way you would treat a hint of a crack in the dam that holds back the reservoir above your town. You do not celebrate, you go and check the dam. I will be honest and tell you the story is not entirely closed, because the frontier never quite closes. In recent years, some physicists have gone back to the tachyon and to the idea of observers who move faster than light, and have argued, with careful mathematics, that certain superluminal situations might produce only a kind of quantum fuzziness, a probabilistic disturbance rather than a hard, clean, logical contradiction. It is interesting work, and I do not want to wave it away, but I also do not want to oversell it. It is contested. It is frontier. It is not the settled view, and it does not mean someone has built a working anti-telephone. It means the question of how, exactly, the universe enforces its rule is still genuinely alive, still being argued in journals right now, and that is a wonderful thing for a question to be. But step back and look at the pattern, because the pattern is the point. Whether tachyons are forbidden by law, or simply absent from the universe, or present but impossible to control, every road we have walked tonight arrives at the same destination. No controllable signal outruns light. No message reaches the past. No paradox is permitted to form. The neutrinos fell back into line, the cable was tightened, the order of time held. And that raises one last beautiful question. If the universe keeps slamming this door with such consistency across particles and ships and tunnels, then how is it doing it? What is the guardian, exactly? And along the way we will meet a few things that look, at first glance, as though they have already broken the rule, and discover why they have not. Is less than break time equals 1s, is greater than number, part 11. The impostors that only look faster than light. Before we meet the guardian, we should clear away 3 famous impostors, 3 phenomena that get pointed to again and again as proof that the universe lets things outrun light. Each one is real. Each one is genuinely strange. And each one, when you look closely, fails the single test that actually matters, the test that decides whether time is in danger. The first impostor is quantum entanglement, the thing Einstein himself called spooky action at a distance. When 2 particles are entangled, measuring one of them seems to instantly fix the state of the other, no matter how far apart they are, across a room or across a galaxy, with no delay at all. It looks for all the world like an instantaneous influence, faster than any signal could carry. But here is the catch that saves causality. The outcome of each measurement is random, and you cannot choose it. So although the two particles are perfectly correlated, you cannot use that correlation to send a chosen message. You only discover the connection later, when the two observers compare their notes through an ordinary channel, a phone call, or a letter, traveling at or below the speed of light. Physicists have proven this rigorously and given it a name, the no-communication theorem. Entanglement looks like faster-than-light influence, but it carries no controllable information, and so it builds no anti-telephone and threatens no paradox. The second impostor is a soft blue glow you may have seen in photographs of nuclear reactors, the eerie light that fills the water around the reactor core. That glow is called Cherenkov radiation, and it is caused by particles traveling faster than light. But faster than light in water, not in empty space. Light slows down when it passes through water to about 3/4 of its top speed, and a fast particle can outrun light in that medium while still staying comfortably below the true cosmic limit, the speed of light in vacuum. So, the blue glow is a real and lawful faster-than-light effect, and it breaks no rules at all, because the rule was never about water. It was always about the ultimate speed, the speed of causality, and nothing in that reactor pool comes close to it. The third impostor is the largest of all, the expansion of the universe itself. The most distant galaxies are racing away from us faster than light, and that is not a mistake or an exaggeration, but nothing is moving through space faster than light. Instead, the space between us and those galaxies is stretching, new distance being created everywhere at once, and the stretching adds up across enormous gulfs until the total recession outruns light. You cannot ride that expansion to send a message, and you cannot use it to reach the past. It is space growing, not anything traveling, and so once again the order of time is untouched. Notice what unites all three: entanglement, the reactor glow, the fleeing galaxies. Each looks, at first, like a violation of the speed limit. And each fails the one question that decides everything. Can you use it to send controllable information faster than light through empty space? For the entanglement, no. The outcomes are random. For the glow, no. It is only fast in water. For the expanding universe, no. Nothing is travelling at all. And because the answer is always no, none of them lays a finger on cause and effect. This is the sharpest possible statement of what the paradox truly requires, and I want you to hold it as we turn toward the end. The danger to time was never speed alone. It was never mere correlation, never a glow, never the stretching of space. The danger is, and has only ever been, controllable information outrunning light through the open universe. That, and that alone, would let the reply arrive before the question. That, and that alone, would build the loop that cancels itself. The impostors are free precisely because they cannot do this one thing, which leaves us with the deepest question of the night, the one we have been circling since the very first minute. The universe seems to allow every harmless look-alike and to bar the one genuinely dangerous act with a consistency that is almost suspicious. So how does it do it? Does it forbid the time machine outright, or does it simply, quietly, make sure the paradox can never quite close? Is less than break time equals 1s is greater than number, part 12, how the universe refuses the paradox, and what that says about time. Physics offers three answers to that question, and I want to lay them out for you the way a fellow traveller spreads a map on the ground at the end of a long walk, not to tell you which road is right, because no one yet knows, but so you can see where the roads go. The first answer came from Stephen Hawking in 1992, and he gave it a name that I have always loved for its dry humour. He called it the chronology protection conjecture. The idea is that whenever the universe gets close to forming a time machine, close to bending space-time into a loop, that would let the past be reached, the quiet fluctuations of empty space, the tiny flickers of energy that fill even perfect vacuum, would surge and pile up at exactly the wrong moment and tear the would-be time machine apart before it could ever function. In Hawking's own phrase, the laws of physics conspire to keep the universe safe for historians. It is a conjecture, not a proven theorem, and proving it for certain would require a complete theory of quantum gravity, which we do not yet have. But the spirit of it is this. Perhaps the universe does not so much forbid the time machine by decree as destroy it by reflex, the way a body flinches from a flame. The second answer is older and stranger, and it belongs to the physicist Igor Novikov. Novikov said, in effect, maybe time loops are allowed after all. Maybe the equations do permit a path that circles back into the past. But if they do, then only one kind of story is allowed to play out along that path, a perfectly self-consistent one. In Novikov's universe, you simply cannot do anything that would create a contradiction, not because a law forbids you in the moment, but because the only events that ever actually happen are the ones that fit together without paradox. The bullet meant to kill the grandfather always, somehow, misses. The cable that would have proven faster-than-light neutrinos is always, somehow, loose. The probability of any paradox-making event is exactly zero. It is a chilling and beautiful idea, because it suggests the timeline is not so much protected as rigid, already written, with no room for the contradiction to squeeze in. Physicists have even tested the idea with imaginary billiard balls sent through wormholes back in time to knock their earlier selves off course, and found that consistent solutions always exist, that the ball can always be made to graze itself instead of blocking itself, that the story can always be told without breaking. The third answer is the most science fiction of the three, and it comes from the world of quantum mechanics, suggested by the physicist David Deutsch. It says that perhaps a traveller into the past does not return to the same history at all, but branches into a different one, a parallel version of events. You could prevent your grandparents from meeting in that branch, and there would be no contradiction because the you who made the trip came from a different branch where they did meet. The loop never closes on itself because it was never quite a single loop. It is speculative, and it leans on ideas about parallel histories that are themselves far from settled, but it is a real proposal made by serious people, and it deserves its place on the map. There is one more thought I want to leave with you underneath all three answers, because it reframes the whole question. Relativity, the theory we have leaned on all night, quietly suggests that past, present, and future may all exist together, equally real, as a single finished fabric, the whole of space-time laid out at once. Physicists sometimes call this the block universe. And if that picture is right, then the very idea of changing the past may not even make sense. There would be no separate, flowing now standing outside the fabric, no moment of decision hovering above it all, in which the change could be made. The past would simply be a place that already is, as fixed and unalterable as a chapter you have already read. In that picture, the paradox does not need to be forbidden, because there was never a loose thread for it to pull. What I find most telling about these three answers is that not one of them is comfortable, and not one of them lets faster-than-light travel through. Hawking's universe destroys the time machine before it can run. Novikov's universe allows the machine, but rigidly forbids the contradiction, robbing you of the free choice that made the paradox possible in the first place. Deutsch's universe lets you act, but only by splitting the world, so that your action lands in a history that was never quite your own. 3 different escape routes, 3 different philosophies of how reality is put together, and every one of them arrives at the same quiet refusal. You may not send a controllable message into your own past. The door stays shut. The physicists do not even agree on which lock is holding it, and still it holds. That, more than any single calculation, is what convinces me that the prohibition is real and not merely a gap in our knowledge. When every road through a forest, however different, comes out at the same wall, you begin to suspect the wall was the point of the forest all along. So let me bring us all the way home, back to the image I asked you to hold at the very beginning. We started by calling the speed of light a speed limit, a number painted on a cosmic road sign, and we spent the night discovering that it is nothing of the kind. It is not a barrier that holds us back. It is the thread that holds everything together. It is the single rule that keeps your yesterdays from spilling into your tomorrows, the rule that guarantees for every observer in all of creation that the cause comes before the effect, that the question comes before the answer, that the story is told in an order everyone can agree on. The speed of causality is the universe keeping its own narrative straight. And so the thing we most wish we could break, the light barrier, the cosmic speed limit, the rule that pins us to the slow crawl between the stars, turns out to be the very thing that lets there be a before and an after at all. To cross it would not be a triumph. It would be the cutting of the thread, and with the thread cut, the message could cancel itself, the cause could erase its effect, and the universe would be asked to hold a story that cannot be told. The limit is not a cage the universe built around us. It is the spine of the story the universe is telling, and we are a few of its sentences. It is a strange comfort, when you really sit with it, that we live inside a cosmos so committed to the order of its own tale that it would rather forbid us the stars than allow a single contradiction. Tonight, as you drift off, you can let that settle over you like a blanket. Somewhere out there, light is still racing across the dark at the only speed it has ever known, holding the past behind it and the future ahead, keeping every before in its place before every after. And the very rule that will not let us outrun it is the same rule that lets this moment, your moment, right now, be a real and settled thing, finished and whole, before the next one quietly arrives.